Hello, this is a Constraint Actor tutorial for the May 2011 release of UDK. My name is Barrett Hudson, and I'm a student at the Guildhall in Cohort 16. Today is June 4th, 2011. Today we're going to be creating a swinging gate for this chain link fence we've built here. As you can see, we've built most of this chain link fence out of blue static meshes, but this one here is a green K-actor. Meaning it has physics simulations on it. If you want more information on K-actors and how to build them and put them in your world, you can see my basic physics tutorial, and it'll walk you through how to set up a K-actor. So let's get started with our constraint actors. And to add a constraint actor, we first need to open up our content browser and navigate to our actor classes tab. And if your physics actors class isn't already expanded, go ahead and expand it out. And what we want to use is an RB hinge actor. We could also use a prismatic actor, pulley joint actor, or BS joint actor, as these are all actually just instances of RB constraint actors. They all have the same parameters, they just come with different preset values, and any one can be turned into any of the others by changing those values. So we'll start with the RB hinge actor. We can right click in our world and we see add RB hinge actor here. We'll go ahead and select that, and we'll see this little green lozenge looking thing appear, and if we click off it, it turns gold. So that's what constraint actors look like in the world. Now we can close out of our content browser, and the first thing we need to do is line this up with where we want our actor to pivot around. Basically, when we start this to set this constraint actor up, we're going to set it up as a pivot for this fence post. For this fence piece, and we want it to pivot around this fence post. So we'll line it up so it's more or less in the center of that fence post. Once we get it lined up where we like it, we can go ahead and press F4 to bring up its properties menu, and we'll expand out the RB constraint actor tab. And the first thing we see is constraint actor 1 and constraint actor 2. This tells the constraint actor which two objects in the world it's going to constrain together. We want it to just constrain to the world. Basically, we want to take this piece of fence right here and tell it that it can only move in certain directions related to the world, not related to any other object. So to do that, we'll leave constraint actor 1 blank and put this fence piece in constraint actor 2. And we'll do that by coming up here and clicking this lock selected actors icon. What that basically does is locks our properties menu to the currently selected actor, allowing us to go back into our viewport and select a different actor without changing which properties we're seeing. So with our fence piece selected, we can click this green arrow here next to constraint actor 2, and we'll see that that becomes this K actor, which is the editor name for this physics piece. Now we've told it what we want to constrain. We need to tell it how to constrain those two actors together, and we'll do that by expanding this constraint setup menu. And we're concerned with the linear first. We can look into this RB constraint setup, and this basically is for constraining skeletal meshes or rigid bodies that have bones. If you want to constrain certain bone movements or things like that, you can set that up in here, but since we're just using a basic K actor, that doesn't really apply to us. And we'll look into our linear tab here, and this is the first thing we really want to check. And we want to make sure that our linear X and linear Y and linear Z are all set up properly. And we can do that by just looking over here, which gives us a basic breakdown of how they're set up. And you can see they all say B limited and then limit size. B limited is basically saying whether or not movement in that direction is limited, 1 being true, 0 being false. So we are limiting in both the X, Y, and the Z directions, which is good. And then limit size is how big it will let that move, how far it will let it move in that direction before limiting its movement. And we can say that that's set to 0 for all of them, which is good, meaning it's not going to allow them to move in any of those directions at all. So that's all set up properly. We don't want our gate moving around, we just want it pivoting around that pivot, not changing its distance from that pivot, and that's what that's going to do. So we can close that, and we'll open up our angular tab, And here we see swing limited and twist limited. This is just like the linear x, y, and z. This is telling it whether or not it's going to limit the swing and the twist of this object. So checked is true, yes it will limit, and unchecked is no it won't. So we want to go ahead and check twist limited. Basically swing, as you can see down, we've got swing 1 and swing 2 as we look down here at our limit angles. And swing is basically if you stick your arm out to the side and move it forward and back, that's swing 1. If you move it up and down, that's swing 2. Twist is essentially with your arm out to the side. If you rotate your arm like you're going to open a doorknob, that's twist. So we'll go ahead and set up our swing limits here. Again, swing 1 is forward and backward, which is how we want our gate to swing. So we'll go ahead and set that to 90. And the way that swing limits work is that they are that number of degrees in either direction from its current location and related to the pivot. So 90 will actually let our actor move 180 degrees, 90 degrees in each direction from its current location. Swing 2, again, that's up and down. We don't really want our gate to sort of rotate up or pivot up, so we'll leave that at 0, meaning it won't let it move in that direction at all. And then twist would be like we were going to open a doorknob or sort of twist it around an x-axis. We don't really want it to twist in that direction at all, so we'll go ahead and set that to 0 instead of 45. Some of the other parameters you'll see in both the linear and angular setups are soft. You can set the limits to being soft, and what that essentially does is instead of being a hard limit where once that limit is reached it's going to stop all motion, it basically acts like a rubber band where once the limit is reached you can push the actor further, but the further you push it the harder it's going to fight you. The limit stiffness applies when you have a soft limit and tells it how hard it's going to be to move an object past its limit, and the limit damping tells it how much force the limit will absorb when it hits a soft limit. So if it's moving with 500 units of force, if you have a linear limit damping of 200, that'll be decreased to 300 units of force after it hits the limit. So finally we've got breakable, which you can set for, again, you can go down and see these are all properties in the angular as well. And breakable essentially allows you to set a constraint that if enough force is applied to it, it can be broken. So we could set it up so that if you applied enough force to our gate, you could rip it off its hinges. And the break threshold is how much force it takes to actually break the constraint. We don't really want that for this gate now, so we'll just go ahead and leave those unchecked. And I think we're set up and ready to go. So we can close that, and if we right click on our world and say play from here, we can get out our force gun. We see we've got our gate and our fence. It's working pretty well. We can apply a force with our force gun and our gate swings open, and we can walk in and we can apply another force to it and swing it the other way, and you can see we've got a working gate. So that's pretty cool. That concludes our basic setup. I'll have another tutorial video that will go into more advanced setup and how to take this gate and make it do some more things.